Inductors and inductive reactance. An inductor is a component that stores energy in the form of a magnetic field. In its simplest form, an inductor is simply a wire loop or coil, usually wound around a magnetic core. Inductance is the property of a circuit, or component, that opposes the inherent change in current of an AC circuit. The moving magnetic field produced by a change in current causes an induced voltage to oppose the original change. Inductance is directly proportional to the number of turns in the coil, and depends on the radius of the coil, and the type of material in the core. Figure 6.21 illustrates the schematic symbol for an inductor. Figure 6.21 schematic symbol for an inductor. If you connect an inductor to an AC voltage source, the current through the inductor will change continuously because the inductor offers continuous opposition to the current flowing through it. This opposition is inductive reactance, and it depends on the rate at which the current is changing and the inductance, ability to oppose, of the inductor. Transformers. A transformer changes, or transforms, an alternating voltage at a given rate to a higher or lower voltage. If you take a simple transformer apart, you will find two separate coils wound around an iron core, because it is essentially an inductor. Figure 6.22 shows the schematic symbol for a transformer. NP equals 20. NS equals 10. Figure 6.22 schematic symbol for a transformer. The alternating voltage from a voltage source, an alternator, or a distribution power line, connects to one coil, called the primary winding. The other coil is the secondary winding. It does not connect to the primary winding or any voltage source, but it connects instead to the load. To transform an AC input, or affect electromagnetic induction, apply a voltage source to the primary winding. This induces a secondary voltage in the secondary winding, and then the secondary voltage flows through to the load. The voltage that we apply to the primary winding is the primary voltage, and the induced voltage is the secondary voltage. Voltage transformation depends on the ratio of the number of turns in the primary winding to the number of turns in the secondary winding. The formula for determining the transformation ratio is NP/NS, or NP/NS, where NP is number of turns on the primary, and NS is the number of turns on the secondary. So if NP equals 200 turns, and NS equals 10 turns, you have a turn ratio of 20:1. Exam alert. You need to know how to determine the turns ratio between primary and secondary turns of a transformer. The applicable formula is NP/NS or NP/NS. You should know about two types of transformers, step-up transformers and step-down transformers. Power companies use both of these types on a large scale. They generate a high alternating voltage, use a step-up transformer to step it up to a still higher voltage, and then transmit it through power lines over long distances to the point of usage. At this point, step-down transformers change the high voltage to a lower value, and then the transformed electric power is applied wherever it is needed, at a lower, safer, and more convenient voltage. Transformers can also have an equal number of turns. The purpose of this is to condition the input voltage. Step-up transformers. If a transformer has more turns in the secondary winding than in the primary winding, the secondary voltage is higher than the primary voltage, and it is a step-up transformer. For example, imagine that an alternator generates a voltage of 2300 V, but the transmission lines carry the electric power at 230,000 V. A step-up transformer must connect between the alternator and the transmission line, and must have 100 times more turns than the primary. Step-down transformers. If a transformer has more turns in the primary winding than in the secondary winding, the primary voltage is higher than the secondary voltage. This means that the voltage has been decreased or stepped down. For example, imagine that the voltage available from the distribution line is 4600 V, and the motors used in a plant have a rating of 230 V. A step-down transformer needs to connect between the distribution line and the motor to step down the voltage from 4600 V to 230 V. Because the secondary voltage must be 20 times lower than the primary voltage, the secondary winding of the transformer must have 20 times fewer turns than the primary winding, and the turns ratio will be 20:1. Amplifiers. Generally, an amplifier, or amp, is a device that takes a small input signal and creates a larger output signal. It increases the amplitude of an audio or other electrical signal in voltage or current, while at the same time minimizing waveform distortion. The relationship of the input to the output of an amplifier is the transfer function, and the magnitude of the transfer function is called the gain. Amps can be a large piece of equipment, such as a guitar amp, or they can be as small as an electronic component on a circuit board. Rectifiers, diodes, and inverters. Two more components that you need to know are rectifiers and inverters. A rectifier converts an AC input to DC. A common application for a rectifier is the battery charger. On the other hand, an inverter converts a DC input to AC, such as the inverters that you use when you are traveling to plug your laptop into your car's electrical system. Rectifier. Diode. Figure 6.23 schematic symbols for rectifiers and diodes. A diode is a semiconductor that has two active electrodes between which a signal flows, and is used to allow electric current to flow in only one direction, and to block the current in the opposite direction, sort of like an electronic check valve. This property is often called the rectifying property of the diode. Thermocouples. A thermocouple is basically a thermal sensor that works like a switch. It measures the heat between 2 points in a circuit and, depending on what the thermocouple is being used for, can close a circuit at a designated temperature or open a circuit to protect it from overheating. Thermocouples are used in a number of applications, from protecting a recessed light fixture from overheating to closing a circuit or opening a valve. Electrical safety. The Asvab covers a couple questions on general electrical safety. In the sections that follow, we discuss topics that you need to know for the test. Discharging a capacitor. It is important to note that after you have charged a capacitor, it will remain charged even after you have removed the input voltage. How long it remains charged depends on its capacitance. Some capacitors can remain charged for 24 hours or more, some larger capacitors for even years. Never touch a capacitor, no matter how small it looks, with your hands, even if you are wearing a grounding strap. Before you ever work on any electrical or electronic circuit, you must always discharge the capacitor. To discharge a capacitor safely, use a high wattage resistor comparable to the capacitance of the capacitor, or a capacitor discharge tool. However, the Asvab might ask you about discharging a capacitor, and gives as the correct answer placing a screwdriver across both the negative and positive terminal of the capacitor. Although you need to know the right answer, the practice itself is not sound. Electrical fires. An electrical fire is just that, electrical in nature, and far different than other types of fires. Electrical fires can result from old, damaged, or overloaded conductor wire. Because water is an excellent electrical conductor, you cannot extinguish an electrical fire with a regular fire extinguisher, or with water. Attempting to do so can mean fatal electrocution. To extinguish an electrical fire, use a C-class fire extinguisher, which is also called a CO. 2. Or non-conductive extinguisher. If the fire is relegated to a small device, for instance, a toaster, unplug the device from the power source, if practical, and extinguish the fire. However, if the fire is a result of faulty wiring or is large, call the fire department immediately. Do not resume using the circuit until you and/or the fire department determine the cause of the fire and correct the problem.